So the next thing I'll do is to use a single script to achieve everything at the same time. And to do that, I'm going to clear here. I have a file here already named aligner.sh, which will perform all the steps that I mentioned earlier at the same time for each of the files, for each of the peers, okay, at the same time. And to do that, let's try to see what's inside the aligner.sh using our nano text editor. So yeah, like always, you first of all call bash, okay, bash, the location of bash on your computer. Then samples, we mentioned the ID, or in your case, it might be accession numbers, IDs. Then you call Brewer-Wheeler aligner to build the index for the reference, which you can do this at any of the stages, but I prefer to do it first. Then the next thing is to create a folder called repair, create a folder called alignment. Then the next thing is to use a for loop to iterate over each sample in your folder. So create repair.sh. That's the first thing you do. The first thing is to correct for disordered read, repair your trimmed reads. Then you call the trim reads, we forward the reverse using sample, okay, since you specified sample here. And then you use this $sign, don't always forget to keep in track. Trimmed reads, sample, then input one, that's input one, input two, then output one, output two. Then another thing I would love you to always never forget is the apostrophe. Even experienced users report that they forget this apostrophe here, okay? And then after that, you specify your output single as well, then echo. So what I did is to echo the present working directory just to know. It's kind of while I was debugging. You can remove it if you wish. Then the next thing is to perform your Brewer-Wheeler alignment. Then yeah, you perform your Brewer-Wheeler alignment. Then you specify the samples, because this time around I created a folder called repaired, if you see here, because I want to forward all my repaired files from repair.sh into this folder. So I specify repaired here, and then it forwarded them into the repaired folder. Now, then to now perform Brewer-Wheeler aligner, I call repaired, and then forward, call repaired, and then look for the file itself using sample as well. It's still the same set of samples. Then, yeah, I call the forward, I call the reverse, and then I pipe it using this into samples view, flag B. So flag B is supposed to be the keyword for BAM files for compression, right? And then it now creates, so I'm using alignment map folder this time around, not alignments, just to create some sense of difference, so you can see the difference at the end of the day. Then you specify alignment map, and then pushes this sample name, because it's not going to, the BAM file is no longer in separate forward or reverse this time around. It's together as one. So you can push your BAM file as a single file into your alignment folder, and then you specify done at the end of a for loop. So let's try to implement it. Hopefully it works. To do that, you bash it, and then yeah, aligner.sh. Hopefully it works. Yeah, so it's working. It's quite fast as usual, because our samples are quite small. And then yeah, so both hopefully it's almost done. Just a few more seconds. Yeah, it's done. So both hopefully if you have some time, you can review the log, and you should notice that this was where I was saying it should tell me the present working directory, zero alternate contigs, reads this, and then it's able to output it, and then this is the time it took for this. What's this sample? Drisdale, okay. And then to finally put this to bed, you can say ls flag lh. Let's see our repaired folder. Yeah, so they are all here, including their single merged outputs. You have them here. And then you can also, let's check for our alignment map. Hopefully we have, yeah, alignment map. Yeah, so we have them here, and then you can try to see if it works. So fine, it works. If you remember, comparatively, if you wish to compare in terms of comparison, you can say, let's compare ls, lh, and compare with our alignment folder. Yeah, so if you see, remember, we performed AC Barry at first, and that was 3.7 megabytes, but this is AC Barry.bam compressed format, and we have 818 kilobytes. And you can imagine the percentage of compression if you love to calculate percentages. And so that saves a lot of our space, that saves a lot of our time as well. I mean, going forward, it saves a lot of time. You can later perform things like sorting, things like even indexing the BAM file itself. But at this stage, I think we are done, and you can take your time to review the steps. If you have questions, please drop them in the comment box, and I'll be willing to respond to your questions. Thank you very much.